Hello friends, this is Mr. Katenda. Welcome to the Home of Science and Home of Science Paper 2 and Mathematics. You are welcome. Okay, let's answer that question from 2023 internal examination, section C, question 1. Let's answer that question. We discuss it. Okay, the question reads, the flow diagram shows how lime is manufactured. The flow diagram shows how lime is manufactured. Okay, so from the diagram there we have substance X, and then when that substance X is undergoes decomposition, so which is decomposition of substance X, it produces calcium oxide, and then hydration of calcium oxide produces substance Y, and then that substance Y, through the process A, it goes back to substance X. Okay, so friends, just to simplify this diagram which is here, this diagram is what we call the lime circle. So this is the diagram that we call the lime circle. Okay, so the lime circle goes like this. We have calcium carbonate. I'll be writing in symbols, chemical symbols. So we have calcium carbonate, and then this calcium carbonate through the process decomposition. So decomposition of this calcium carbonate, which is there, it will produce calcium oxide, which is CaO, and the gas which is calcium, which is carbon dioxide, which is CO2, will leave this reaction here. So during the decomposition of calcium carbonate, there will be a gas that will be produced, which is carbon dioxide. Now, a gas will leave the reaction there. So we only get calcium oxide there. Okay. Then this calcium oxide, when it for us to obtain calcium hydroxide with that symbol Ca, then the hydroxide in brackets with the 2, which is the valence of calcium there. So for us to obtain this calcium hydroxide from calcium oxide, meaning it is hydration. And hydration is the process of adding steam or water in general. So the process of adding water to a substance. So when water is added to calcium oxide there, it gives us calcium hydroxide. And then the calcium hydroxide there, then they have to bubble through to this calcium hydroxide, they have to bubble through carbon dioxide, which is a gas, or carbon dioxide gas is bubbled through this, and then it will go back to calcium carbonate there. So it's actually the circle that we call the lime circle. So the process here, there is also a process here which has been asked, by the way. So the process here from calcium hydroxide to calcium carbonate, it is the process whereby carbon dioxide is bubbled through this in order to give us calcium carbonate plus water. Okay, so the process there, it will be, this is the process of adding carbon dioxide, which is carbonation. Okay, so carbonation is the process of bubbling carbon dioxide to this calcium hydroxide to give us calcium carbonate there. Okay, so this is how the circle is. So now let's get to the answer to the question. So the question there, I want you to be able to see this diagram alongside. Okay, so there. Okay, so now let's get to the first question. Okay, so they are saying A, name the process A. Yeah, so it is the process from calcium hydroxide, which they are saying substance X here, to calcium carbonate. I mean, which they are saying substance Y here to substance X. So what is this process A? So process A, we know it is in carbonation. So the carbonation, which is here, carbonation. Okay, so that is the process A. Okay, let's go to the next question. A2, write a balanced chemical equation for process A. Okay, so they want us to write the balanced chemical equation for process A. Okay, so in order for us to write the balanced chemical equation for process A, we need to know substance Y, and we need to know what is used there for process A in order to obtain substance X. So we have discussed that already. We know that substance Y, it is in calcium hydroxide. Okay, and then process A, we have said they use carbon dioxide, so it is plus carbon dioxide. And then what will this give us? It will give us substance X. So substance X, which is the one we have identified here, this substance X, the one we have identified as calcium carbonate. Okay, so here it will produce calcium carbonate. What else? And also it will give us water. Okay, so it will give us H2O. Okay, so now here we only need to balance this chemical equation. Okay, so let's see what we have there. So calcium, this side it's 1, also the other side is 1. Okay, oxygen, we have these 2, because this 2 is for whatever that is in the brackets here. Then we also have these 2 again. So oxygen, this side, left side, we have 4. Even the other side, we have 4. There is this 3 plus 1, 4. Okay, then carbon we have 1 here. Okay, the other side also carbon, it is 1. So this chemical equation, just to derive it, it is self-balanced. So that is the balanced chemical equation. No need to balance it. So that is A2. Okay, so A1, we said it is carbonation. Okay, so A2 for the balanced chemical equation, that is our balanced chemical equation. Okay, we move on. B, describe how substance Y would be used to test for the presence of a named gas. Okay, so a named gas here, it is in a named gas here, it is carbon dioxide. So how can we use calcium hydroxide to test for the presence of carbon dioxide? That's what the question is saying. So this substance Y, which we have identified as calcium hydroxide, okay, so this substance Y should be dissolved in water. Now, under hydration here, in order for us to obtain this, it means it is already dissolved in water. So if this substance Y, which is calcium hydroxide, is in sorry, so this calcium hydroxide here, which has been formed by the process of dissolving calcium oxide in water, or addition of water to calcium hydroxide, which we are calling hydration, then it means this one, we have a substance which is already dissolved in water there to give us an aqueous solution there, okay, which is calcium hydroxide. So now How can we prepare it? It's just to dissolve this same substance Y if in solid state. We dissolve it in water, and then when we dissolve it in water, it will form an aqueous solution of substance Y, which is an aqueous solution of calcium hydroxide. Okay, so the aqueous solution of calcium hydroxide here, which is substance Y, will be the one that will be used to test for the gas, which is carbon dioxide. But how? So we have saying is what we are explaining. So substance Y will be dissolved in water, and then the gas will be bubbled through the solution for substance Y, and then there will be some bubbles there that will be formed, and substance Y will turn milky. So this substance Y is what we call lime water. So the identity test for carbon dioxide, we know it turns lime water milky, which is substance Y when it is dissolved in water. So the question is, describe how substance Y would be used to test for the presence of a named gas. So substance Y should be dissolved in water to form an aqueous solution of substance Y, and then the gas will be bubbled through, which will in turn turn the aqueous solution of substance Y milky. So we are saying, okay, so that is B. Okay, so substance Y is dissolved in water to form an aqueous solution of substance Y. Then a gas will be bubbled through, which will turn the solution milky. So we say carbon dioxide turns lime water milky. Okay, so that's it. C. Okay, C. Give a metal that would be purified by substance X after its extraction. Okay, so it is iron. I'll explain. So C1, it is the iron. Okay, on the extraction of iron, we have three materials which are fed into the blast furnace for the extraction of iron. We have three materials there. Number one, we have the ore. It can be hematite or magnetite. Okay, then so hematite 1, 2, we have coke or carbon. 3, we have limestone, which is calcium carbonate. Okay, so the purpose of limestone in the extraction of iron there, it is what they have said here. It is to purify the metal, which is iron, during its extraction. Okay, so they have said give a metal that would be purified by substance X after its extraction. So it is iron. Okay, we move on. So we know before we move on, we know in the extraction of iron, the materials there, it is coke, limestone, which is calcium carbonate, and the hematite. So the same calcium carbonate is used there to purify the metal after its extraction. Okay, next question now. C2. Write a balanced chemical equation that shows reduction during extraction of the metal you have given in C1. Okay, write a balanced chemical equation that shows reduction during extraction of a metal you have given in C1. Okay, so hematite, which is the iron ore. So we show the balanced chemical equation from where this iron metal is extracted from. So hematite, it is iron 3 oxide. So the formula for iron 3 oxide, it is Fe2O3 plus, and then the reducing agent in this extraction is carbon monoxide, which is CO. Then it will produce iron metal, which is Fe plus carbon dioxide. Okay, now the question is, write a balanced chemical equation that shows reduction during extraction of metal you have given in C1. So the metal, it is iron. So this is how the metal is extracted from its ore, which is hematite. So this is solid, this is gas, solid, this is the gas. Now we just balance it. Okay, so how do we balance it? So here iron we have 2, here iron it's 1, so we put a 2 here to balance iron, so iron balanced. Now oxygen we have 3, 4, but here we have 2. Okay, now if we put a 2 here to balance oxygen so that it becomes 4, carbon will be affected here. It will have 2, and then you will be required to put a 2 there, meaning also the oxygen atoms will increase there. Okay, now what can we do? We have to put a number for carbon here and also for carbon here, but that the number that should be here, it should make the oxygen atoms equal to the ones which are on the left side. Okay, so 2 cannot go there. So what if we put a 3 here? Meaning oxygen atoms, we are going to have 6, because it will be 3 times 2 there, 6. And then if we put a 3 there to balance carbon, we already have 3 oxygen atoms here, so plus the 3 that will be there, then it will give us 6. Okay, so 3 is just fine. So we put a 3 here, so carbon 3, oxygen 6. So here also a 3, carbon 3, oxygen 6, which is this 3 plus this 3 to give us 6. So just like that, the equation is balanced. Okay, we move on. We go to D. Okay, so D reads, state one use of a named alloy of the metal you have given in C1. So the metal in C1, it is iron. So the alloy which is made from iron, then we give in one use. Okay, so one alloy which is made from iron, it is steel. Okay, which is an alloy of iron and carbon. So what is the use of steel? So steel is used to make bridges. Okay, bridges, or steel is used to make those steel nails. Okay, so we have said, state one use of a named alloy of the metal you have given in C1. Okay, so we are saying it is D what? It is D1. So we say steel, and then comma steel. So how is the steel used? So steel used to make steel nails. Yeah, so we say to make steel nails. Okay, so those steel nails that they use in concrete nails, they are made of steel. Okay, or we can say stainless steel. So what is the use of stainless steel? Okay, so stainless steel is used to make cutleries for example, cutleries in hospital. Stainless steel is used to make razor blades. Stainless steel is used to make knives. So that is about stainless steel. Now we have just gone for steel, which is an alloy of iron and carbon, which is used to make steel nails. Okay, we move on. D2, the last one. other than alloying, how would you, other than alloying, how would you prevent the metal you have given in C1 from corrosion? Other than alloying, how would you prevent the metal you have given in C1 from corrosion? Okay, so in C1, we gave the iron. There, the answer is iron. So, apart from alloying, how can we prevent this metal ion from lasting or from corrosion? Okay, so how can we prevent it from corrosion? So, here it is by painting. So we say painting. Okay, for example, roofing sheets made from iron, how are they prevented from lasting? It's by painting. So most roofing sheets are painted there so that the oxygen and the water cannot come in contact with the iron metal there, so that corrosion cannot take place there. So by painting there, we protect our iron metal there. Okay, thank you so much. This has been the Home of Science, Paper 2 and Mathematics. Kindly invite more of your friends to my YouTube channel to subscribe so that we can keep on growing. Thank you.